Yeah, good afternoon, everybody. My name is Heinrich Schuchardt. I'm working at Canonical in the foundations team, and my role is being the RISC-V lead engineer. I've joined the company 2 years ago, and besides my work at Canonical, I'm the maintainer of the UEFI implementation in Ubuntu. You may have been listening to John Ronco's talk, which was giving an overview of what RISC-V is, what the ecosystem looks like. And this talk is a bit different. It's just trying to get you using Ubuntu on your RISC-V devices. And here's just an overview of the agenda. So we'll start looking into what hardware is available. We will look into how is it booting, how you can emulate RISC-V with a Docker or virtual machine, what is the state of the software on Ubuntu, and then give an outlook what needs to happen next, because this ecosystem is evolving really fast. So here you just see all those boards that we have been supporting. So we started spinning images in 21 with a Sci-Fi Hi-Fi Unleashed and Unmatched boards. Last year, there were a lot of smaller development boards coming up. So we have brought support for the Lishi Dock, for the NASA D1, for the Starfire Vision 5. And one board that's a bit special is Microchip Polar Fire Icicle Kit. That's a board that you would use if you wanted to do FPGA development in connection with RISC-V. And this year we have been working on the Starfire Vision 5.2 board, which is really great because it has NVMe on it, it has USB 3.0 on it, and it's affordable. And that has really been the decisive point for deciding which board to work on. Has a good upstreaming story both on U-boot and in the kernel. So if you would ask me today, what should I buy? That really depends on your use case, of course. If you say, I just want to see RISC-V running, I don't want to spend much money, then maybe the Lishi Dock is the right thing for you. 25 euros is just the cost of a meal. And but you can run our Ubuntu packages on it. It has Wi-Fi on board so that you can get into the Ethernet, but it's as low powered as a Raspberry Pi Zero, let's say. If you look into this Starfire Vision 5.2 board I already talked about, it's about $130 or euros, and it comes with 4 cores. It has an NVMe drive, USB available, and I think that's enough to make some serious development on it. If your daily work is RISC-V and you really depend on build speed, you could get a Milk-V Pioneer box. It's nothing that we officially support, but they are spinning a daily Ubuntu image and just would run fine. So I used it to compile LLVM, and instead of compiling it natively on an unmatched board in 3.5 days, it just took me 6 hours. And of course, if that's your job, that makes a difference. So if you have bought your board, you need to find the software. Unfortunately, currently if you go on ubuntu.com on downloads, it's a bit hidden under Ubuntu for IoT. There you find an entry for RISC-V. If you click on it, you will get to the real download page where for every board you will find the images. For the Vision 5.2 board and for the unmatched board, you will not only find pre-installed images on an SD card, but also installer images to directly install onto your NVMe drive. And you will find the link to the wiki, because on some boards you have to do some preparative work. The Starfire Vision 5.2 comes with U-boot pre-installed, but that U-boot is too old. And I've packaged an upstream U-boot into PPA. And as soon as the next version of U-boot is getting into Noble, we will then have it in the main archive. If you boot up your board, the first thing you will see on the serial port is OpenSBI, and you may be wondering, what's this? It doesn't sound like Ubuntu, which I might have expected. And to understand this, we have to look a bit into the architecture of RISC-V. So you may have seen on x86 or ARM that typically there are different security levels at which software is running. So on x86, you might be running on ring 0, 1, 2, and so on. On ARM, you have exception levels 3, 2, 1, 0. And the same is also existing in the RISC-V world. So machine mode is the most privileged mode. So that has access to every register, can do anything. And this is not where your kernel will be running. The kernel will be running in supervisor mode, and the user lands then in user mode. And between the supervisor mode and machine mode, there has been an API defined because some of the firmware, and that's OpenSBI, is remaining resident to provide services like reboot or power off, for instance, and others. And yes, that is why we need such a facility. And if in future there will be boards that support virtualization, there will be even an extra layer, the hypervisor, and the hypervisor will talk to the machine mode firmware by this SBI interface, and the same interface will also be used between the operating system then running in virtual S mode, talking with the hypervisor. So yes, these are the things that OpenSBI does. It supports unaligned access if your processor doesn't do it. It emulates some missing instructions maybe. It has a debug console so that you get very early output. It system reset, suspend power offs, start and stop the different cores, or as RISC-V calls them, hearts. Performance traces are supported by the SBI interface, and a lot of more things are currently developing and coming up in SBI. If you look into the boot flow, all our boards use Uboot currently. So there's Uboot SPL that is loading a so-called fit image which contains OpenSBI and main Uboot. And from there we then boot into grub, and grub finally loads Linux. So on the serial console you will see the grub menu where you can choose whether you want to use the most recent kernel or the one previous one. Yeah, and so the boundary between machine mode and supervisor mode is just between OpenSBI and Uboot. If you think about the interface between Uboot and grub, this is UEFI. So we really try to boot the RISC-V boards as we would boot an x86 or an ARM machine. In future, Uboot will be replaced on some boards by what is called EDK2. EDK2 is also an implementation of UEFI and is the basis of most of the firmware that we find on our laptops. And yeah, while Uboot is just implementing a subset of the UEFI implementation, EDK2 is giving a full implementation. And companies like Star5 with their Vision 5.2 board, or Zofco with Pioneer board, they are really trying to get EDK2 running, upstreaming patches currently. And this looks like a good story because it would be great for having a full EDK2 experience, especially once RISC-V is entering the server world. Yeah, and on Debian, there's already EDK2 package for RISC-V. And once we have upgraded our QEMU, we will also get that package for EDK2. And then in QEMU, you will also be able to boot via EDK2 if you want to. Yeah, maybe you don't want to buy a board, or you haven't bought a board yet. Then you still can try RISC-V, just spin up a virtual machine. So what you need as packages is, as you have when looking at the boot flow, that's clear. You need OpenSBI, you need Uboot. There's a package called Uboot QEMU. You need QEMU, and then you can start it up, and then you're passing OpenSBI and Uboot to QEMU. If you are on Mantic, you will not need to pass the OpenSBI because there's already one built in. And yeah, then you are just running like on another machine, but of course a bit slower due to the emulation. You can also run a RISC-V Docker image, and you don't need a RISC-V machine to run a RISC-V Docker image. You can do it on your AMD 64 or ARM 64 laptop. And unfortunately, currently we are not yet packaging regularly updated Docker images and putting them on Docker Hub. But what I did here is simply I took an Oracle cloud image for RISC-V, wrote a very small script Docker file which just says from scratch take this archive and bash is my console, and then you can run a Docker build X, and it takes a few seconds, and then you have your Docker image available on your laptop, and then you can start running it. If you run it and type uname A, which will give you which Linux is running on it, you will see that it shows RISC-V running, and you may wonder how this is done. If you in a different console just type in psaux grep QEMU, you will find, yeah, QEMU is running in the background. So you just type docker run, but in the background it will have been spinning up QEMU to do the emulation. So what is the state of the software ecosystem? If you look at the number of binary packages, you have for AMD 64 something like 71,000. And as you see on the chart for RISC-V, we have something like 66,000. So we have most of the packages available, but of course there are still some missing, and this needs maybe to be worked on. But I mean, for the developer experience, it's really looking great. I mean, you have all main languages there, like Python, Java, Node, Go, C, C++, PHP. There's one big exception still in our offering. Oops. Yeah, .NET. There is upstream work going on for .NET, but it's not yet available in our snaps or in our Debian archives. As I already said, virtualization and Docker is working. It's not only working on your laptops that you can start the tools, you can also start them inside running Ubuntu on RISC-V, and LXD is also working. The desktops are available, so GNOME and KDE is available, and if you have an unmatched board, you are lucky, or if you have a Pioneer box, you're also lucky. Our kernel team, Emil is here, they are working on getting also external graphics card working on the Vision 5.2 board. It just needs some more upstream patches that are being worked on. Probably you want to use your board to build your own software. And if you are in a virtual machine or in Docker image, it's trivial. It just looks like any other architecture. So in this example, I'm just using pull LP source to download the source for package, apt-get install all the package dependencies, and then simply run the package build package. And I have my, in this case, my Hello application, but it also works for LLVM or whatever complicated package you have. There's no difference, essentially, whether you package for RISC-V or for x86. If you want to build a snap, then I could manage doing it in a Docker, but you can do it in a virtual machine or on real hardware. The one thing that you really have to observe when building snap is that the RISC-V machines don't come with virtualization support yet. And this means you have to use a container for building your snap. And this is done if you call snapcraft use LXD. And yeah, up here you will see, of course, if you have a first-time user of LXD, you will have to initialize it. But otherwise, Snap's building works fine. For instance, the installer that we have on our installer images is Ubiquiti, and that's a Snap that's just built in the same way. When we look into Launchpad, and if you have recently created a PPA and try to enable some architectures, you will have found you can enable anything but RISC-V. And you may be wondering why. The reason is that up to now the build capacity has been limited, and our Launchpad team has told me that within this year they expect that they will be able to offer everybody access to building on RISC-V, not only to canonical employees like it's done today. So let's look into the future. I don't know how many of you have seen John Ronco's talk. He has already told you a bit about different profiles, but for those who haven't been here, so we have RISC-V. This was invented with some machine instructions, starting really only with integers. And afterwards, new machine instructions have been defined, and these definitions have been collected into what is called RISC-V ISA extensions, instruction set extensions. And so there's an extension for multiplication, division, for atomics, and so on. And currently, and these different extensions and then are collected into what is called a profile. And one of the current profiles is RWE20, which has been created in, you guess it, 2020 or 2021. It has finally been fixed. And there's are also new profiles like RWE22, RWE23 is currently worked on. And what is a big difference? So with RWE20, you have just the basic instructions like floating point, like integer, atomics, and that's it. With RWE22, we will get things like hypervisor. We will get vector instructions, those that you need if you want to do math. If you want to do AI, you really want to have vectorized, so single instruction, multiple data capabilities. And with RWE23, which is still being revised, vector and hypervisor will become mandatory. RWE23 will also give us vector crypto, so that there are also commands that you can really very much speed up things that are related to encryption, be it AES or be it HTTPS protocols. And what's also very interesting is that pointer masking extension. So many JIT engines are using some bits of their pointers for the internal purposes, and this pointer masking will give a speed up to JIT engines like Java, for instance. So where are we now with Ubuntu? Oops. So if you run gcc dump specs, or you just take a binary and run readelf on it, it will spit out a long string which describes which extensions are available. So there are some single letter extensions in the beginning and multi-letter ones at the end, but in the end it's a bit less than RWE20, what we are currently doing. And you might say, okay, there are all these other very interesting instructions. Why is Ubuntu looking like this? Just look at the hardware. So if you look at the hardware, all the boards that I've talked about are RWE20 or less. And that's the reason why we stand here as it is, with something like RWE20. But the landscape is going to change. So there has been an announcement by Milk5 that they will take a Xi5 core, which has compliance with RWE22, and they will be bringing this board to the market end of next year. If you look into RWE23, that is not even ratified, and of course there are no boards available, but a lot of those extensions already can be emulated with QEMU. But as I said, it's going to change. We are seeing the RWE22 boards coming out next year. Possibly in 25 or 26, we will see then RWE23 boards. And of course, software has to evolve to make use of those extensions. And there are two approaches of it. The one approach is what can upstream do for it. And so the kernel provides an interface via a syscall to detect which extensions are available on the board. And this can be used by upstream software to decide the extension is available, and I use a different code to run when I have vectorizations than I run when I don't have vectors enabled. And this is supported also by GCC, for example, which provides what is called indirect functions or ifuncs. And I've just created one simple example here. So down here you find a function main, which wants to call something that I called test. And this function test is not implemented anywhere. Instead, you find a definition which says, if you want to find out how test is implemented, call resolve test. And here's the implementation of resolve test. I didn't detect any extensions. I simply looked at what time is it, and is this time even or odd? And depending on the time, it calls test 1 or test 2, which I implemented up here, which just print out odd or even. And yeah, when I run this very simple example, then depending on the time, I get those two outputs. So even before main is running, this resolving of the functions is done. So resolve test is the thing that's really called first. It sets up the pointers so that then main can jump into the right function. Then main is invoked, and then test 1 prints out odd, or test 2 prints out even. So this is what upstream could do. And then we have to think about what can our distro do. And there are different approaches also on the distro side. So what's feasible today already? We can set up a PPA or another archive, add this to our sources list, and use up pinning to say, yes, this repository has priority to everything that Ubuntu is publishing. And that way you could already say, yes, on my computer, I'll always pull in the package, maybe using vector extensions. What we're currently investigating is whether we can build packages multiple times with different compiler settings, put them all onto Launchpad, and then at install time, when you say apt-get install, find out, okay, I'm currently running on a machine with vectors, so I install the vectorized version of the package. But this is still future investigation. It will also need coordination with Debian, because we share, of course, the source for apt with them, and this is looking into the future. Another thing is, as I said, we have currently a base profile, a profile saying, okay, we are just a bit below RWA 20. And as new hardware is coming up, we will have to think about, okay, how long does this make sense? How long are those boards that we are supporting today really of importance to us? And maybe in 2604, we will see then a raise in the ISA profiles that we are using. But that will really depend on the market needs that there are. So we don't know how much hardware will be available or which hardware will be available in 26. And this, of course, will be decisive for our way we go. And yeah, this was an outlook on the software side. As a last slide, let's have a look at what's coming up next in hardware. So we have been collaborating with silicon vendors in the past years, and Sci5 has been a major partner here. And Sci5 is going to bring out a board which is called a Sci5 Hi5 Pro P550, which is much more powerful than what they had once as an unmatched board. I already have one machine at home to test it, and I think it will also be demoed in Santa Clara at the RISC-V Summit, and I'm excited to see this. And our collaboration goes so far that we want to see it coming to the market just with Ubuntu already pre-installed, or as on an SD card at least. Yes. So this brings me to the end of the talk, and I'm available for your questions.
Okay. Just one question though, regarding the GPU support. Is it usable to have GPU via PCIe interfaces normally that exist from AMD and NVIDIA? Do they actually work on this?
Yes,
RISC-V
so
board?
I've been running both AMD graphics cards as well as NVIDIA ones. So the NVIDIA GT 710, which is an older card I've been using, and other people have been using newer AMD cards. Both run. You can also connect it to the Star 5 board, for instance, but then you will, okay, you need the adapter on the one side, but currently it only works with the vendor kernel. And the unmatched board currently and the Pioneer box are currently the ones that you could really use for desktop work. Any other questions?
So quickly, what is the Rust support for RISC-V?
Rust?
Rust.
Yeah, Rust is available. Just apt-get install it.
You didn't mention on the slides for the languages.
Yeah, sorry, it's not my personal favorite language, but there are so many more. I mean, I have been programming in Erlang, and Erlang also works on Rust. The slide is limited, yes.
Beginner in this group, I don't want to install anything. Is there a way, like in the modern times, we have WASM running in the browser and you can run Python in it. Can I emulate RISC-V there?
Currently, we don't have a web page where you can test RISC-V, no. So we don't have a remote desktop for a RISC-V engine. Or, Emil, you have an answer? Or?
So it's not Ubuntu, but I think he's called Fabrice Bellard or something, who did the initial QEMU, and he's actually made like a tiny emulator that runs in your browser. So yeah, you can.
Yeah, I think I've seen something with Fedora running on RISC-V emulated via WASM, so WebAssembly. Yeah, thanks a lot, and